So I just saw this on Reddit. It says we are going to factor x to the 7 plus x to the 5th plus 1. Easy, right? Because we can just look at this and say this is equal to x to the 7 plus x to the 5th plus 1 times 1. Yes, this is indeed equal to that, but we are not going to consider this as a factor of that. Because the goal of factoring is to write the original polynomial into a product of two polynomials with less degrees. This one right here, it's the same as the original. Of course, you can always put something as something itself times 1, right? But it doesn't do us anything. Anyways, though, it has to be a polynomial here, and the degree has to be less than 7. Likewise, this also have to be degree less than 7. Polynomial means that we have to have positive integer power. Okay, so how exactly can we do it? Before I show you guys the solution, let me tell you guys a common mistake. A lot of people will look at x to the 7 plus x to the 5th plus 1 and see we have these two terms, and we can factor out x to the 5th. Aha, I agree. And then if we do that, we get x squared plus 1 and then plus 1. It seems like we factored this something already, but this whole thing is not the factoring of the original. Of course, this is equal to that, but again, we are trying to get this as a product of two polynomials with less degrees. We still have a sum of this thing and 1, so this is also not the factoring of that. So how exactly are we supposed to factor it? How are we supposed to factor this? This is with 7th degree. Is it possible? Yes, let me show you. So here's the deal. Sometimes when we want to factor a polynomial, the more, the better. As we can see here, we only have the 7th power and also the 5th power. What happens to the other powers though? The 6th, the 4th, etc., right? So why don't we invite them to join the party as well? So that being said, I'm going to look at this as x to the 7, and then I'm going to add x to the 6, and then we have x to the 5th already. And then I'm going to add x to the 4th, x to the 3rd, x to the 2nd, plus x. And then right here we still have the plus 1. Of course, once we add them up, we will have to subtract it immediately so we can keep this as the original. So we will also have to subtract x to the 6, and then right here we have to subtract x to the 4th, and then subtract x to the 3rd, and then x to the 2nd, and then x. So far so good. So this is what I try first, and let's see if this is going to do us any good. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's not a good number because it's a prime number. Now we cannot really group them into like a nice number of terms. What I mean by that is if you try to look at this as 4 groups of 3s, right here, if you look at this, first group, second group, what's the third group? I can't really do anything, right? Yeah, because it's the x plus 1 and all that. So perhaps let me just try to do it like 6 groups of 2 with 1 left over though. But let's see. This 2, and then this 2, this 2 right here, and then this 2, so far so good, and then this 2, but we have an x left. If you kind of pair them up, you will see that this right here we can factor out x plus 6, and then we get x plus 1, and then continue, we can factor x to the 4th. And it looks kind of promising because we see the x plus 1 in common, and then if you continue, that's x squared, x plus 1, and then this right here, I'm going to factor out 1, so plus 1 times x plus 1. So far so good. However, once you get to here, if you factor out x to the 4th, then we get x to the 4th, perhaps with a minus in the front, then this becomes x squared, x to the 4, but that's minus, we took out the minus here, so it becomes plus 1. That doesn't really work anymore. If you continue right here, minus x squared, yes, you get x plus 1, but you have the minus x. So this is what I tried first. it didn't really work that well because of these terms here. So I thought about it, like what exactly is the issue here though? Again, because we have 13 terms. What if we have even more? Right here, we are subtracting 1, 2, 3, 4, 5 terms. Not really good. What if we subtract another x to the fifth? I know we have x to the fifth already, so I will just have to add it. That way we can pair up more terms. So let's try that, yeah? So here is the correct solution. Right here, I'm going to keep this as x to the 7th, but I will start adding x to the 6th, and then I would like to add another x to the 5th. Right there, put down the original x to the 5th, and then just keep adding x to the 4th, x to the 3rd, x squared, and then x, and then lastly we have the plus 1. And now we will have to subtract all the terms that we just added. So minus x to the 6th, minus x to the 5th, minus x to the 4th, x to the 3rd, x squared, and then minus x. Now we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's a very nice number because we can look at this as 5 groups of 3s. Very nice, huh? Here we go. I am going to start off by looking at the first 3 terms, and we can factor out x to the 5th. And then we will get x squared plus x plus 1. Continue the next 3 terms, we can factor out x to the 3rd power. Very nice, huh? And then we will get x squared plus x plus 1. Does it look promising? Yes, it does. And then these 3 terms happens to be like this. We are going to factor out a 1. And then we still have x squared plus x plus 1. And then remember, groups of 3s, right? So I'm going to pair these 3 terms. I'm going to factor out minus x to the 4th power, and this will give us positive x squared, and then positive x, and then positive 1. Aha! And then the last 3 terms here, we factor out negative x. And we will have same thing. Yeah, I'm looking at these 3 terms. So x squared plus x plus 1. Okay. Now, everybody has x squared plus x plus 1. So I'm just going to factor that out. So this becomes x squared plus x plus 1. And then we'll just have to put all the terms in red in the second parentheses and we'll be done. Start off by saying x to the 5th here. And let's put this in a nice order. We will have the minus x to the 4th. And then we will add x to the 3rd. And then there's no x squared. Be careful. We have a minus x. And then lastly, we have the plus 1. Yep, just like this. And as you can see, we have successfully factored the original polynomial into a product of 2 polynomials with less degrees. This is degree 2, this is degree 5. So this is how you break it down. Can you continue though? Yes, but you will have to use complex numbers. For this one, and for this one, ideally speaking, you can still factor even with complex numbers, but for the 5th degrees, it's very, very difficult. I doubt if you can find like nice exact answers for the factorings for that. But anyways though, I will just stop right here.